Look around you. This vibrant blue marble, teeming with life, bathed in the gentle embrace of its star. It feels immutable, eternal. But what if I told you the universe holds a predator far more terrifying than any alien armada, more destructive than any supernova, an enemy you can't see, can't hear, yet it's out there right now, a silent hunter, a cosmic nomad. And if one were to enter our solar system, what then? For eons, our cosmic neighborhood has been a sanctuary, a ballet of planets dancing in predictable harmony around our sun. We've built civilizations, written symphonies, gazed at the stars with a sense of wonder, and perhaps a touch of security. But the universe is a place of profound beauty, yes, and unimaginable violence. And sometimes its most dangerous inhabitants are the ones you never see coming. We're talking about rogue black holes. These aren't the supermassive monsters lurking at the heart of galaxies, anchoring billions of stars. These are stellar mass black holes, the collapsed remnants of giant stars that burned themselves out, imploded, and then got kicked out of their home galaxies. They're the cosmic drifters, the silent assassins, roaming the interstellar void with immense gravitational hunger, completely unseen. They don't glow. They don't reflect light. They are quite literally invisible. Imagine trying to spot a shadow in a pitch-black room. That's a rogue black hole. So, how do we even know they exist? Well, sometimes the universe leaves clues. If one passes in front of a distant star, its immense gravity can bend and magnify that star's light, a phenomenon we call microlensing. It's like looking through a warped pane of glass. You don't see the glass, but you see the distortion it creates. Our telescopes, incredibly sensitive now, are constantly scanning for these telltale distortions. We've found a few. We know they're out there, potentially billions of them, scattered across our galaxy alone. And one of them, statistically, could be on a collision course with us. Let's imagine it. Let's run the simulation, not as a fantastical sci-fi flick, but as a chillingly realistic projection of physics. We're talking about a black hole roughly 5 times the mass of our sun. Not a behemoth, but certainly enough to unravel everything we know. It's coming from the depths of interstellar space, moving at a speed typical for these cosmic wanderers. It's heading our way. The first whispers of chaos wouldn't be seen, but felt. Not by us, not yet, but by the outer reaches of our solar system. Picture the Oort cloud, that vast icy shell of comets and frozen debris, stretching almost a light year from the sun. It's a silent, frozen archive of our system's birth. But as the rogue black hole approaches, its invisible hand reaches out. The delicate gravitational balance that holds those icy worlds in check would begin to unravel. Comets, once locked in slumber for millennia, would be violently jolted from their orbits, hurled inwards towards the sun, like a cosmic shotgun blast. Scientists, our modern-day seers, would be the first to notice unexplained bursts of long-period comets showering the inner system, would raise alarms. They'd point their telescopes, run their models, and then one day, perhaps a faint, telltale gravitational lensing event, a subtle warping of background starlight, would confirm humanity's worst nightmare, a rogue black hole. And it's coming. Panic would ignite across the globe. What do you do when the end of the world isn't a meteor or a solar flare, but an invisible force of nature that simply can't be stopped? There would be no escaping it, no grand evacuation. We'd be passengers on a condemned ship, watching the inevitable approach. As the black hole drew closer, say, to the equivalent of a light year away, the gravitational tremors would grow stronger. Neptune and Uranus, those distant ice giants, would be the first planets to truly feel its pull. Their perfectly elliptical orbits, honed over billions of years, would start to warp, to wobble. They'd begin to dance, an erratic, unsettling jig around the sun. No longer predictable, no longer stable, their delicate rings, their icy moons, would experience unprecedented tidal forces, possibly even breaking apart. It would be like watching the first few pieces of a perfectly assembled clock fall away, signaling a far deeper malfunction. But the real show would begin when this silent hunter breaches the inner Oort cloud, perhaps half a light year out. Now, the Kuiper Belt, home to Pluto and countless other icy dwarf planets, becomes a gravitational pinball machine. Billions of icy bodies, some the size of small moons, would be ripped from their stable paths. Many would be flung out into the interstellar void, forever lost. But many more, billions more, would be slung inwards, like cosmic cannonballs, directly towards the sun, and tragically, towards us. Imagine a sky constantly alive with meteor showers, not just a few shooting stars, but a relentless barrage, culminating in impacts that would make even the dinosaur-killing asteroid look like a pebble. Our atmosphere would burn bright, with constant fiery streaks day and night. Then, the true chaos. The black hole enters the inner solar system, maybe 100 astronomical units out, roughly 3 times Neptune's distance from the Sun. Now, the gravitational influence becomes undeniable, overwhelming. Jupiter and Saturn, the gas giants, those colossal anchors of our system, would begin to feel its titanic pull. Their immense masses, once a stabilizing force, would now become liabilities. Their orbits would violently contort. Their majestic rings would be torn into disarray. Their myriad moons would be ripped from their gravitational embrace, either sent hurtling into deep space, or worse, smashed into their parent planets, or even into each other. A cosmic demolition derby of unimaginable scale. This isn't just about things getting knocked around. The black hole's gravity wouldn't just pull, it would distort. Imagine the entire fabric of space-time around us being stretched and twisted. An invisible churning vortex. The very light from our sun would appear warped, distorted. The constellations in our night sky no longer recognizable, smeared across the heavens like paint on a canvas. And then, Earth. At roughly the distance of Jupiter, our world would feel the tremors, not just from the incoming black hole, but from the gravitational storm raging through the solar system. The sun itself, though massive, would begin to wobble, its steady light flickering as it too reacted to the intruder. On Earth, we'd experience catastrophic, unprecedented tidal forces. Our oceans, once held by the gentle pull of our own moon, would become monstrous, rising and falling by hundreds of feet, unleashing tsunamis that would scour coastlines clean, reshaping continents in a matter of days. But it wouldn't just be the water. The very crust of our planet, miles thick, would groan and buckle under the immense strain. Earthquakes, magnitudes beyond anything ever recorded, would tear across every continent. Supervolcanoes, dormant for millennia, would erupt with devastating fury, spewing ash and magma into the atmosphere, plunging our world into an endless, toxic twilight. The air itself would be ripped at, great gusts of atmosphere screaming into space, leaving us gasping, exposed. Life, as we know it, would be pushed to the absolute brink, clinging to existence in the rapidly collapsing ruins of our world. We'd be living through a living nightmare, every second a desperate fight against the inevitable. As the black hole draws even closer, perhaps to the distance of Mars, the sun's gravitational hold on Earth would weaken drastically. Our planet would no longer be a loyal satellite. It would become a rogue world itself, pulled directly towards the invisible maw. The black hole's gravity would be so profound, so intense, that it would begin to exert differential forces. The side of Earth facing the black hole would be pulled dramatically harder than the side facing away. This is where the term spaghettifications comes from. It sounds almost cartoonish, But the reality is nothing short of cosmic horror. Imagine our planet, this beautiful, vibrant blue marble, being stretched like taffy. Mountains would be ripped from their bases. Oceans would boil and vaporize in an instant. The very ground beneath our feet would tear itself apart. Continents would fracture, then elongate, stretching into impossible, grotesque shapes. The atmosphere, what little remained, would be peeled away like an onion skin. In its final moments, Earth wouldn't just break, it would be unmade. Every atom of our world, every ocean, every mountain, every memory would be drawn out into an impossibly thin stream of matter, stretched beyond recognition, until it was nothing more than a whisper of plasma, a cosmic filament, before being pulled past the event horizon. The point of no return. Once past that boundary, not even light can escape. Our world, our history, our future would simply vanish, swallowed by the silent hunter, leaving behind no trace, no echo, just an empty space where a vibrant solar system once thrived. Then, silence. The screen goes black. For the universe, it was a fleeting event, a cosmic ripple quickly forgotten. For us, it was the end of everything. But this terrifying scenario, this silent hunter, is just one of countless cosmic threats we barely understand. How do we, as a species, navigate a universe so profoundly beautiful, yet so utterly indifferent to our existence? What else is out there lurking in the dark? And what untold stories of life and death, of creation and destruction, are waiting to be unveiled? The journey, it turns out, has only just begun. The journey, it turns out, has only just begun. We've peered into one terrifying possibility, a rogue black hole on a collision course. But to truly grasp the nature of such a cosmic menace, to understand the storm, we first have to understand where it comes from. How does something so utterly destructive, so impossibly dense, even come into being? And what cosmic cataclysm could rip it from its stellar nursery, casting it adrift, a silent, invisible assassin in the vast, unforgiving darkness? Our story begins not in the cold void, but in the heart of a star. Not just any star, mind you. We're talking about the titans, the behemoths of the cosmos, stars that dwarf our own sun by factors of 10, 20, even 100 times. Imagine a star so massive, so incredibly energetic, that its core is a fusion furnace beyond our wildest comprehension. For millions, sometimes even billions of years, these stellar giants wage an epic battle, a delicate cosmic dance. The outward pressure from the ceaseless nuclear fusion, converting hydrogen into helium and then heavier elements, pushes against the relentless inward pull of gravity. It's a precarious balance, a cosmic standoff that defines a star's entire existence. But even the mightiest furnace eventually runs out of fuel. For these colossal stars, the end comes not with a whimper, but with an earth-shattering bang. Once the core can no longer fuse elements, once it's exhausted its hydrogen, its helium, its carbon, its oxygen, its neon, its magnesium, its silicon, all the way up to iron, the game is over. Iron, you see, is the cosmic dead end. Fusing iron actually consumes energy rather than releasing it. And when that happens, the outward pressure vanishes. Poof. Gravity, the ultimate victor in this cosmic wrestling match, now has free reign. And it doesn't just win. It utterly dominates. The star's core, no longer supported, collapses in on itself with breathtaking speed. In mere milliseconds, an object hundreds of thousands of miles across implodes, crushing itself down to an unimaginable density. It's like taking all the matter of Mount Everest and squeezing it into a single grain of sand. The outer layers of the star, caught in this catastrophic implosion, rebound off the super-dense core with such force that they explode outwards in one of the most spectacular events in the universe, a Type II supernova. For a brief, glorious moment, this dying star can outshine an entire galaxy. It's a cosmic fireworks display of unimaginable scale, forging and scattering the very elements that make up planets, life, and even us. But what remains after the fireworks fade? If the original star was massive enough, if its core was roughly 3 times the mass of our Sun, or more, then even the supernova's incredible outward force isn't enough to halt gravity's relentless grip. The core keeps collapsing. It shrinks past the point of being a neutron star, where protons and electrons are crushed into a sea of neutrons. It shrinks past every known form of matter. It becomes nothing, or rather, a singularity, a point of infinite density, where the laws of physics, as we understand them, simply break down. And around that point, a region of space-time so warped, so profoundly curved, that nothing, not even light, can escape. We call it a black hole. Think of it like this. Imagine dropping a bowling ball onto a trampoline. It creates a dip. Now imagine dropping something infinitely heavy, infinitely dense, onto that same trampoline. It wouldn't just dip. It would tear a hole right through it. That's essentially what a black hole does to the fabric of space-time. It's not a cosmic vacuum cleaner, sucking up everything in sight. That's a common misconception. If our Sun were suddenly replaced by a black hole of equal mass, Earth wouldn't get sucked in. We'd just continue orbiting it, exactly as we orbit the Sun now, albeit in eternal darkness. No, a black hole is a cosmic trap. If you stray too close, if you cross that invisible boundary we call the event horizon, then you're done. Game over. There's no coming back. So now we understand how these monstrous entities are born from the fiery crucible of a dying star. But that's only half the story. Most black holes, the ones we know about, live fairly orderly lives. They reside peacefully at the centers of galaxies, like our own Milky Way, or remain gravitationally bound within the stellar nurseries where they were born, often in binary systems orbiting another star. But every now and then, something truly extraordinary happens. A cosmic accident, a gravitational ballet gone horribly wrong, and a black hole, once a fixture of its stellar neighborhood, is violently ejected, becoming a rogue, a ghost in the void, a cosmic nomad silently traversing the interstellar medium, a phantom hunter with an insatiable gravitational appetite. How does a behemoth like this get orphaned? There are a few scenarios. One common mechanism involves a dance of 3. Imagine a binary star system, 2 stars locked in a gravitational embrace, one of which eventually collapses into a black hole. Now, introduce a third massive object, another star, or even another black hole. Into this delicate waltz, the gravitational interactions become chaotic, unpredictable. It's like a cosmic game of billiards, where the balls are stars and black holes. The interloper might steal one of the partners, or more dramatically, it could impart so much kinetic energy to one of the objects that it's slingshotted out of the system entirely, launched into the lonely depths of space. Another way involves the sheer chaos of galactic environments. Picture the dense, crowded cores of young galaxies, or globular clusters, where hundreds of thousands, even millions of stars are packed together. These are cosmic mosh pits, where close encounters are common and gravitational tugs are constant. A newly formed black hole, or even an existing one, might get caught in a multi-body interaction, receiving a powerful gravitational kick from a cluster of stars or other massive objects. It's like a cosmic pinball machine, and our black hole gets shot out of the table. Then, there's the grandest scale of all, galactic mergers. When 2 galaxies collide, they don't just smash into each other like cars. The stars themselves are so far apart that direct collisions are rare, Instead, their supermassive black holes at their centers merge, and the entire gravitational landscape of both galaxies is violently reshaped. During this epic rearrangement, smaller stellar mass black holes, caught in the wake of such colossal gravitational waves, can be flung out, accelerated to incredible speeds, destined to wander the intergalactic void for eons. Once ejected, these rogue black holes are incredibly difficult to detect. They emit no light, no radio waves, no X-rays, unless they're actively feeding on something. They're invisible, silent. Their only telltale sign is their gravitational influence. Imagine trying to find a single, perfectly dark bowling ball, floating silently through a truly infinite, utterly black stadium. Scientists can sometimes infer their presence by observing the gravitational lensing effect, how their immense gravity distorts the light from background stars, bending it like a cosmic magnifying glass. Or, if they happen to pass close enough to a star or a gas cloud, they might briefly flare as they accrete matter, revealing their location for a fleeting moment. But these events are rare, and the black holes themselves are tiny on cosmic scales. A typical stellar mass black hole is only a few tens of miles across, a minuscule target in the vast ocean of space. The sheer scale of this phenomenon is staggering. Astronomers estimate there could be tens of millions, even hundreds of millions, of these stellar mass black holes scattered throughout our own Milky Way galaxy alone. Most are likely dormant, silent, patiently waiting, and an unknown number of them could be rogue, unattached to any star, drifting through the interstellar medium, completely unseen. They are the ultimate cosmic stealth predators, the true ghosts of the void. This profound realization fills us with a unique blend of awe and apprehension. Awe at the incredible, violent processes that sculpt our universe, forging these ultimate gravitational beasts. Apprehension at the thought of these invisible entities, these cosmic nomads, silently threading their way through the fabric of space, completely indifferent to the worlds they might encounter. Our solar system, our tiny blue marble, is but a fleeting speck in a universe teeming with such unseen forces. We live on a knife edge, utterly dependent on the delicate cosmic balance, a balance we're only just beginning to comprehend. So we've journeyed from the fiery death of a star to the silent, lonely voyage of a rogue black hole. We've understood how these gravitational monsters are born and how they become untethered. But what does this mean for us? What are the true odds of such a silent hunter crossing paths with our vibrant home? And if it did, how would we even know? The clock, it turns out, is always ticking. The universe is always moving. And somewhere out there, a ghost is surely lurking. The question isn't if these cosmic nomads exist, but where they're going, and when their silent journey might intersect with ours. The implications are profound, terrifying, and utterly captivating. What comes next in this cosmic ballet of life and death? What other unseen forces are at play, shaping our destiny in ways we can barely imagine? And how do we, as a species, prepare for the unimaginable, for the threats we can't even see? The answers, like the cosmos itself, are vast, complex, and waiting to be discovered. But one thing is certain: our journey into the unknown has only just begun, and the universe, in all its terrifying splendor, is always full of surprises. The universe, in all its terrifying splendor, is always full of surprises. Most of them are beautiful, breathtaking, mind-bending. But some are the stuff of nightmares. Imagine our solar system, right now. A cosmic oasis, teeming with life, bathed in the comforting glow of our sun. Planets in their stately, predictable dance, a rhythm perfected over billions of years. You and I, safe here on Earth, gazing up at the familiar constellations, blissfully unaware of the silent, invisible predator that might be lurking just beyond the edge of our celestial neighborhood. This isn't about a meteorite with our name on it. It's not a supervolcano about to blow. This isn't about alien invaders or gamma-ray bursts from a distant galaxy. This is something far more insidious, far more fundamental. This is about gravity itself, weaponized. We've talked about rogue black holes, these cosmic wanderers, kicked out of their home galaxies, drifting through the interstellar void like celestial ghosts, invisible, implacable. Their hunger, a gravitational pull so immense, it warps the very fabric of space-time around them. And the terrifying truth? We'd never see one coming. Not with our eyes, not with our telescopes, not in the traditional sense. It's a dark shadow in an already dark universe, a void in the void. But what if one did come calling? What if, right now, as you're watching this, a rogue black hole, perhaps a few times the mass of our sun, was quietly, relentlessly making its way towards us? Not at the speed of light, thankfully, but fast enough that our billions of years of cosmic peace might be about to unravel. What would that even look like? How would humanity, with all its scientific prowess, all its advanced observatories, first detect the approach of an object that literally swallows light? This isn't science fiction anymore. Thanks to incredible advancements in computational astrophysics and mind-bending simulations like Universe Sandbox, we can ask that chilling question, what if? And then we can watch, in terrifying detail, as our serene solar system begins its slow, agonizing dance towards oblivion. Our journey into this simulated cosmic disaster doesn't begin with fire and brimstone. It begins with a whisper, a tremor, a barely perceptible shift in the cosmic rhythm that's governed our solar system for eons. The first signs wouldn't be on Earth. They wouldn't even be near Earth. They'd be out there, in the frigid, distant reaches of our celestial home, beyond the gas giants, beyond the ice giants. Imagine Neptune, a magnificent sapphire marble, more than 4 billion kilometers from the Sun, completing a single stately orbit every 165 Earth years. It's a lonely sentinel, a beacon of icy solitude. For billions of years, its path has been etched into the cosmic fabric, a predictable ellipse, unwavering. But now, in our simulation, something is changing. Something is wrong. Miles per second, Neptune is moving through the cold vacuum. It's a dance of incredible precision, orchestrated by the Sun's immense gravitational embrace. But then, a new partner enters the ballroom, unseen, uninvited. Its gravity, though still incredibly distant, begins to exert a subtle, insidious tug. It's like a dancer, perfectly executing a waltz, suddenly feeling a faint, almost imperceptible pull from an invisible hand in the crowd. A slight stumble, a momentary loss of balance. On Earth, our most powerful telescopes, designed to peer into the deepest corners of the universe, might start picking up anomalies, not direct observations of the black hole itself. Oh no, that's still a long way off, if it ever happens visually. Instead, they'd see Neptune. Its orbit, once so perfectly predictable, would begin to show tiny, inexplicable deviations. A slight acceleration here, a gentle deceleration there, a barely noticeable wobble. Think about it. We've mapped these orbits with incredible precision. We know where Neptune should be, down to the second, for centuries to come. So, when our supercomputers, crunching gigabytes of positional data from observatories like Hubble and James Webb, suddenly flag a discrepancy, a tiny error in the predicted path, the alarms would be quiet at first. Just a few astronomers scratching their heads, running their calculations again. Is our data off? Is there some unknown effect from the sun? Is it a glitch in the telescope? Doubt that most human of emotions would be the first ripple, but the data would persist. The anomalies would grow, not in magnitude, but in consistency. What was once a tiny, random deviation becomes a persistent, albeit small, shift. Then, Uranus, Neptune's icy sibling, would start to show similar subtle signs. Its own predictable journey around the sun, a majestic 84-year cycle, would begin to waver. Imagine a perfectly tuned pendulum clock, suddenly, almost imperceptibly, losing or gaining a fraction of a second every swing. It's not broken, not yet, but something is interfering with its fundamental rhythm. This isn't a sudden catastrophic collision. This is the slow creep of a gravitational tide. Our rogue black hole, still millions of miles away, is already flexing its cosmic muscles. Its gravitational field is like an invisible hand, reaching across the vast emptiness, gently but relentlessly nudging these planetary titans. For Neptune and Uranus, these nudges are initially tiny, perhaps a few hundred meters per year off their predicted path, then kilometers, then tens of kilometers. Over the span of months, years, these small changes accumulate. They are the first tremors of a cataclysm yet to unfold. But the ice giants aren't the only residents feeling the first chilling breath of this cosmic ghost. Beyond Neptune lies the Kuiper Belt. Think of it as a vast icy donut of ancient relics, billions of comets, asteroids, dwarf planets like Pluto, frozen remnants from the early days of our solar system. It's a quiet, cold, and incredibly stable place. Or it was. Now, the black hole's distant gravitational pull begins to agitate this dormant region. Imagine a still pond. Now, drop a pebble into it. The ripples spread. That's what's happening in the Kuiper Belt. The black hole's gravity doesn't just pull. It stretches, it twists. It creates tidal forces even at these unimaginable distances. Suddenly, the billions of objects in the Kuiper Belt, from tiny specks of ice and rock to dwarf planets hundreds of miles across, are no longer in perfect equilibrium. Their orbits, once so stable, so predictable, start to get perturbed. Some might be flung slightly inward, others outward. It's like stirring a colossal beehive, but instead of bees, it's a swarm of icy cannonballs, each a potential harbinger of doom. This is where the first real alarms might begin to blare. Professional and amateur astronomers alike, constantly scanning the skies for new comets and asteroids, would start to notice an uptick in activity. More objects straying from their expected paths. Comets that should be dormant, suddenly getting kicked out of the Kuiper Belt and beginning a long, slow, terrifying journey toward the inner solar system. These new comets, some perhaps never seen before, would appear on our cosmic doorstep, their trajectories baffling, their origins mysterious. Where did this one come from? A bewildered astronomer might ask, staring at their screen. It doesn't fit any known orbital pattern. It's like it just appeared. The data would be confusing, contradictory. Some objects accelerating, others decelerating, all in ways that don't make sense with the sun as the sole gravitational master. The Kuiper Belt, once a frozen library of cosmic history, is becoming a shooting gallery. At this stage, the rogue black hole is still too far to pose an immediate, direct threat to Earth. But its influence is undeniable. The scientific community, initially skeptical, would transition to puzzled, then to deeply concerned. Teams of astrophysicists would be formed, working around the clock, trying to make sense of the growing catalog of orbital anomalies. They'd be running simulations, checking their models, desperately trying to find a known natural explanation. Perhaps a new undiscovered Planet 9, way out in the Oort cloud. A massive dark gas giant we've somehow missed? The possibilities would be debated furiously, but the gravitational signature wouldn't fit any normal planet. A planet's gravity fades predictably. A black hole's gravity, even at immense distances, has a specific chilling signature, a kind of universal, inescapable pull that warps space itself. And that warp, however subtle, would begin to leave its mark on every object in the outer solar system. Imagine the atmosphere in those observatories, the quiet hum of supercomputers, the hushed voices of brilliant minds, their faces illuminated by the glow of monitors, displaying increasingly worrying data. The initial confusion would give way to a dawning, terrifying realization. We're seeing something new. One scientist might whisper, something else. The term Planet X would be tossed around, then dark matter concentration. But eventually, inevitably, someone would run a simulation with the unthinkable, a rogue black hole. And the moment those numbers align, the moment the simulated trajectories of Neptune, Uranus, and those rogue Kuiper Belt objects finally match the observed data, a cold dread would settle over the room. Because if the math adds up, if the observations confirm the presence of an unseen massive gravitational anomaly, then we're not just looking at a scientific discovery. We're looking at a death sentence delivered on a cosmic scale. The whispers in the data would have finally coalesced into a chilling message. It's coming. This is the agonizing beauty of science in the face of the unknown. The meticulous observation, the relentless pursuit of truth, even when that truth is the most terrifying revelation imaginable. It's the moment when abstract data points coalesce into an existential threat. It's the moment when the calm, rational pursuit of knowledge collides with the primal fear of oblivion. The news would leak, slowly at first, then like a dam breaking. Unexplained orbital perturbations in the outer solar system. New comets from the Kuiper Belt, behaving erratically. The world's leading scientific minds grappling with something so vast, so powerful, so utterly alien to our understanding of a stable cosmos. The fear wouldn't be panic yet. It would be a deep, pervasive apprehension. A sense that something fundamental has shifted, that the rules of our cosmic home are being rewritten, not by us, but by an unseen force beyond our control. We'd be watching, helpless, as our outermost sentinels, Neptune and Uranus, wobble and sway. We'd see the Kuiper Belt, our cosmic attic, suddenly empty its contents, sending icy projectiles hurtling towards us. Each new observation, each confirmed deviation, would be another nail in the coffin of our cosmic certainty. The simulations, once abstract scientific tools, would become chilling prophecies, playing out on screens around the globe. But the black hole is still far. So incredibly far. Does this mean we have time? Time to prepare? Time to escape? Or is this merely the overture to a symphony of destruction, a prelude to a horror that will unfold over centuries, perhaps even millennia? The universe, in its terrifying indifference, offers no easy answers. We are merely bystanders, for now, watching the first uneasy dance of giants, knowing that the music will only grow louder, more chaotic, and infinitely more dangerous. What will happen when that invisible hand reaches further towards the gas giants? When Jupiter and Saturn, with their titanic masses, begin to feel the pull? What kind of chaos will that unleash on the inner planets, on us? The first ripple has been cast. The water is stirring, and the true storm, the real cosmic disaster, is still gathering its unimaginable fury. The clock, it turns out, isn't just ticking, it's screaming. And the next chapter, it's going to be a wild one. Because that invisible hand, the one belonging to our rogue black hole, it wasn't content just to tease the outermost fringes of the Oort cloud. It wasn't satisfied with merely whispering gravitational threats to distant comets. No, it was reaching deeper, its grip tightening on a far more substantial, far more dangerous part of our cosmic neighborhood. The Kuiper Belt. Imagine a vast icy disk stretching from the orbit of Neptune out to about 50 times the Earth's distance from the Sun. This is the Kuiper Belt. For billions of years, it's been a silent, frigid graveyard, home to dwarf planets like Pluto, Eris, and Haumea, alongside a staggering number of smaller, icy bodies, literally trillions of them. Think of it as the solar system's attic, packed with the leftover building blocks from our birth, frozen in time. These objects, usually, are content in their stately, predictable waltz around the Sun. A cosmic ballet of slow, graceful orbits, mostly unseen, mostly unheard. They are the quiet sentinels of our outer system, but quiet no more, as the black hole, invisible and relentless, continued its inexorable approach. Its gravitational field began to ripple through this tranquil realm. At first, it was subtle. A slight tug here, a barely perceptible nudge there. Our telescopes, scanning the deep cold, might have registered a few more icy worlds, wobbling on their axes, or perhaps a minor, inexplicable deviation in Pluto's orbit. For a time, it might have looked like nothing more than an interesting astronomical anomaly. But beneath that veneer of normalcy, the fundamental physics of the Kuiper Belt were being rewritten. You see, the Kuiper Belt exists in a delicate gravitational balance. Every object, from the smallest pebble to the largest dwarf planet, is locked into a stable, long-term dance with the Sun and the gas giants, especially Neptune. Their orbits are often in what we call resonances, rhythmic relationships where one object completes a certain number of orbits for every bonus orbit of another. It's like a perfectly choreographed celestial clockwork. But introduce a new, massive, and utterly disruptive player into this intricate system, and that clockwork doesn't just break down, it shatters. It's like dropping a bowling ball into a perfectly still pond. The immediate splash is obvious, sure, but it's the ripples that truly carry the energy. Those ripples spread, disturbing everything in their path, bouncing off the edges, creating chaos. The black hole was that bowling ball, and the Kuiper Belt, our pond. What happens when those delicate gravitational resonances are violently disrupted? Orbital chaos. Imagine you're on a Ferris wheel, and suddenly, the entire structure starts to sway violently, unpredictably. Some cars accelerate, others slam into each other. Some are flung outwards, others inwards. That's what was happening, but on a scale that beggars belief. The black hole's gravitational field wasn't just pulling on these icy bodies, it was twisting their space-time, warping their gravitational environment. Suddenly, the tranquil, slow-moving objects of the Kuiper Belt were no longer gentle dancers. They became projectiles. The black hole, with its immense gravity, was acting like a cosmic slingshot, or perhaps more accurately, a cosmic pinball flipper. Some of these icy worlds, caught in just the right gravitational sweet spot, were accelerated outwards, flung from the solar system entirely, destined to become interstellar wanderers, lost to the void. A sad, silent escape, but for every object flung out, many, many more were flung in. Think about that for a second. Millions, perhaps billions, of icy, rocky bodies, some the size of mountains, some the size of small moons, that had been orbiting peacefully for eons, were now being violently ripped from their ancient paths. They were no longer following nice, stable ellipses. They were on wild, parabolic trajectories, accelerating to incredible speeds, their destinations the inner solar system. Our solar system. Our home. We're talking about cosmic bullets, and there was no stopping them. Back on Earth, the astronomical community was in a state of escalating frantic alarm. We'd seen the early warnings, the slight perturbations in the Oort cloud. But this was different. This was imminent hue. Telescopes like the James Webb Space Telescope, designed to peer at the dawn of time, were now repurposed, their incredibly sensitive instruments straining to track the accelerating onslaught. Humanity's greatest eyes on the universe were suddenly focused on the rapidly approaching doom. Imagine being a scientist, dedicated your life to understanding the cosmos, only to find yourself witnessing its unraveling in real time. Dr. R.S. Thorne, head of the Planetary Defense Coordination Office, a man who'd spent decades calmly calculating asteroid trajectories, now found himself staring at screens filled with red dots, each one a death sentence. His usual dry wit was gone, replaced by a grim, haunted look. "It's like trying to predict every raindrop in a hurricane," he'd muttered once to his team, rubbing his temples. "Except each raindrop is the size of Manhattan." His team, a collection of brilliant minds from around the world, worked around the clock, fueled by caffeine and an ever-growing sense of dread. Their supercomputers, once used for simulating galaxy formation, now churned through petabytes of data, trying to model the trajectories of literally millions of incoming objects. They were trying to predict where and when these cosmic bullets would strike. But the sheer scale of the chaos was overwhelming. Every calculation was an approximation, every trajectory a guess. The black hole's gravity wasn't a constant, predictable force across the entire Kuiper belt. It was a complex, dynamic, ever-changing field. Small initial differences in an object's starting position or velocity were amplified exponentially by the black hole's influence, leading to wildly divergent outcomes. This is the essence of chaos theory, playing out on a cosmic stage. A butterfly, flapping its wings in the Kuiper belt, could, in theory, alter the course of an asteroid hurtling towards Earth. The problem? There were billions of butterflies. The data streams were a horrifying ballet of red and orange lines, crisscrossing the projected orbits of Mars, Earth, Venus, and Mercury. Each line represented a potential impactor, each intersection a possible apocalypse. The sheer number of objects was mind-boggling. We've always been aware of the threat of asteroid impacts, of course. Scientists track near-Earth objects diligently, and we have plans, theoretical at least, for deflection. But those plans were designed for one asteroid, maybe a handful. This wasn't a handful. This was an entire shotgun blast, fired from the edge of the solar system. The closest we'd ever come to this kind of impact event was 66 million years ago, when a single, albeit massive, asteroid wiped out the dinosaurs. One object. Now, we were facing an onslaught of millions, each one capable of causing continent-shattering devastation. It was like comparing a single sniper shot to a global carpet bombing campaign. The difference was not just in magnitude, but in scope, in sheer, overwhelming inevitability. And the worst part, even the fastest objects, accelerated by that cosmic slingshot, would still take time to reach us. Months, years, decades even for some. Imagine living with that knowledge. Imagine watching the sky, knowing that somewhere out there, an invisible predator had unleashed a torrent of icy shrapnel, and that your number, or humanity's number, was slowly, inexorably coming up. The black hole wasn't just a gravitational anomaly. It was a cosmic catalyst. It was transforming the placid, distant Kuiper belt into a weapon, turning ancient, frozen worlds into instruments of destruction. The solar system, once a picture of majestic, clockwork precision, was now a shooting gallery. And we, the inhabitants of the inner planets, were standing right in the bullseye. The whispers began. whispers of a second great bombardment, echoing the violent early days of the solar system, when our young planets were pummeled relentlessly by debris. But this wasn't the messy birth of a system. This was its violent, orchestrated undoing, as the first fastest cosmic bullets began their long, lonely journey inward. Their paths etched across the vast, empty canvas of space. The question wasn't if they would hit. The question was, where and when? And how many of them? We watched, helpless, as our peaceful cosmic neighborhood transformed into a cosmic war zone. The black hole was still far, its shadowy presence still a distant, theoretical terror. But its children, its deadly, icy children, they were already on their way. And they were coming for us. The gas giants, those mighty protectors, would be next to feel the full fury of the black hole's direct gravitational embrace. But before that, before the titans truly fell, the inner planets would have to contend with the blizzard. A blizzard of ice and rock, moving at speeds we can barely comprehend, each one a harbinger of untold destruction. We thought we had time to prepare for the monster itself, but it seems the monster has sent its advance party. And they're already at the door. What will happen when these cosmic bullets begin to rain down? When our atmosphere, once a shield, becomes a fiery canvas for their final devastating descent. The calm before the storm is over. The storm has begun, its terrible, fiery descent. And the next chapter, it will show us what it truly means to be caught in the crosshairs of the cosmos. We thought we had time to prepare for the monster itself, but it seems the monster has sent its advance party. And they're already at the door. What will happen when these cosmic bullets begin to rain down? When our atmosphere, once a shield, becomes a fiery canvas for their final devastating descent. The calm before the storm is over. The storm has begun, its terrible, fiery descent. And the next chapter, it will show us what it truly means to be caught in the crosshairs of the cosmos. The first whispers of the black hole's true power didn't come as a sudden cataclysmic blow. No, it was far more insidious, like a slow-motion unraveling. For millennia, for billions of years, our solar system has been a finely tuned clockwork, a cosmic ballet of predictable orbits and unwavering gravitational bonds. And then, this intruder, this silent, invisible force, began to tug. Imagine our solar system as a giant, intricate mobile. Each planet, each moon, perfectly balanced, spinning in its own graceful arc. Now, picture an immense, unseen hand, reaching in, gently at first, then with increasing strength, to disrupt that delicate equilibrium. That's what happened when the rogue black hole, perhaps a few times the mass of our own sun, began to exert its will on the outer reaches of our cosmic neighborhood. First, Neptune, then Uranus. These distant ice giants, once serene sentinels, began to wobble. Their vast elliptical journeys around the sun, once so meticulously charted, started to deviate. Astronomers on Earth, glued to their screens, saw the subtle shifts, the tiny, almost imperceptible accelerations and decelerations. It was like watching a perfectly trained dancer suddenly miss a step, then another, a tremor of uncertainty rippling through the performance. It's like the universe itself is breathing in. Dr. Eris Thorne, head of the Deep Space Observatory Project, remembered saying during those tense weeks. His face, etched with a mix of fear and professional awe, was a mirror of humanity's dawning comprehension. You feel the pressure building. You know what's coming. But the scale of it, it's beyond anything we've ever conceived. But the real show, the true terror, began when the black hole's gravitational tendrils reached the gas giants. Jupiter, Saturn, these aren't just planets. They are titans, cosmic heavyweights, each a solar system unto itself, dwarfing all the inner planets combined. For eons, Jupiter has been our solar system's grand bouncer, a colossal shield, deflecting countless comets and asteroids, often sacrificing itself for the sake of the inner worlds. It's got a gravitational field so immense, it could swallow every other planet in our system whole, with room to spare. You'd think such a behemoth would be immune, right? You'd think Jupiter, with its swirling storms bigger than Earth, its magnetic field 1,000 times stronger than ours, would simply brush off this intruder. But against a black hole, an object that warps space-time itself, even a giant like Jupiter, is just a plaything. As the black hole drew closer, Jupiter's orbit, once a majestic, unyielding ellipse, began to distort. Imagine trying to steer a supertanker through a hurricane. That's what Jupiter was experiencing. The black hole's gravitational pull wasn't uniform across the planet. It was a differential force, stronger on the side closer to it, weaker on the far side. This wasn't just a tug. It was a stretch. A planet that had held its shape for 4.5 billion years suddenly felt like it was being squeezed and pulled, its very integrity under siege. The great red spot, that ancient raging storm that's been churning for centuries, began to behave erratically. Its crimson eye, normally a symbol of Jupiter's unwavering power, seemed to flicker, to churn with an unnatural ferocity. Deep within Jupiter's gaseous layers, the immense pressures and temperatures, already extreme, became a maelstrom of unpredictable energy. We saw unprecedented seismic activity, not on a solid surface, but in the planet's vast liquid metallic hydrogen core. It was a cosmic earthquake, on a scale that defies imagination, rocking a world whose ground is a sea of compressed gas. And then Saturn, oh majestic Saturn. Its iconic rings, a masterpiece of cosmic artistry, have captivated humanity for centuries. Billions of ice particles, ranging from microscopic dust grains to house-sized boulders, all orbiting in a delicate, shimmering dance. They are the signature of our solar system, a testament to its beauty and order. And now, they faced their ultimate undoing. As the black hole closed in, its gravitational grip intensified. At first, the rings seemed to shimmer unusually. Telemetry data from our probes, still bravely broadcasting their dying signals, showed the individual particles accelerating, their orbits becoming wilder, more chaotic. It was as if the cosmic ballet had suddenly sped up, the dancers flailing, losing their rhythm. Then, the stretching began. The side of the rings closest to the black hole was pulled harder, faster, than the side furthest away. Imagine a vast, delicate tapestry woven from starlight and ice, slowly, inexorably, being pulled from opposing ends. The fabric of the rings, once so tightly bound, began to thin. Gaps widened, new eerie strands of ice and dust, like ghostly tendrils, began to stretch out into the void, reaching toward the unseen monster. It's like watching a painting melt. A junior scientist, fresh out of Caltech, whispered, her voice barely audible over the hum of the observatory. Her eyes, wide with horror, were fixed on the screen, showing the real-time simulations. The beauty was still there, but it was a beauty twisted, distorted, on the verge of annihilation. The spaghettification, that chilling term we reserve for objects nearing a black hole, wasn't just for planets. It was happening to the rings. Each individual ice particle, each icy boulder, was experiencing its own miniature tidal force. They were being pulled, stretched, elongated, then torn apart. The rings didn't just break. They unraveled. They transformed from a glorious, cohesive structure into an immense, diffuse cloud of stretched-out debris, like cotton candy pulled to an impossibly fine thread, ultimately scattering into the vastness of space. From our vantage point, the last images we received were heart-wrenching. Saturn's once proud halo, now a jagged, asymmetrical ruin. streaks of ice, illuminated by a distorted sun, arced away into the darkness, forever lost to the planet they once adorned. It was a cosmic scream, a silent testament to the black hole's unstoppable power. A structure that had endured for billions of years, eradicated in a matter of days. The beauty was gone, replaced by a haunting spectral aftermath. But the rings weren't the only casualties. Jupiter and Saturn, in their titanic struggle, were no longer the benevolent guardians of their many moons. Io, Europa, Ganymede, Callisto. Jupiter's Galilean moons, each a world of immense scientific interest, potential abodes for life, were ripped from their orbits. Some were flung outward, becoming rogue celestial bodies, destined to wander the interstellar void, frozen and alone, their internal engines of geological activity silenced forever. Others, pulled in terrifyingly close, were subjected to such extreme tidal forces that their interiors were liquefied, their surfaces cracked and torn. We saw simulations of Europa's icy shell shattering, its hidden ocean, once a sanctuary for life, boiling away into the vacuum of space. Then there was Titan, Saturn's largest moon, with its thick atmosphere and methane lakes. A world so Earth-like in its processes, yet so alien in its composition. For a brief, agonizing period, Titan was accelerated, flung like a stone from a cosmic sling, on a trajectory that threatened to send it hurtling toward the sun. Other moons were not so lucky. Imagine a cosmic game of billiards, but on a scale that defies comprehension. Some moons crashed into their parent planets, igniting fireballs that momentarily scarred the already tortured surfaces of the gas giants. Others collided with each other, creating spectacular yet horrifying debris fields. The entire architecture of the outer solar system, once a model of stability, had devolved into a gravitational mosh pit, a destructive dance of unparalleled scale. The immense energy transfer, the sheer unimaginable power unleashed, was staggering. The black hole wasn't merely pulling these planets, it was accelerating them. It was a slingshot, on a scale that defies human comprehension, using the giant's immense mass to gain momentum, subtly altering its own path as it carved its way deeper into our home. And throughout it all, the black hole remained unseen, a ghost in the machine, its presence felt only by the violence it inflicted, the chaos it wrought. It's a terrifying concept, isn't it? The most destructive force in the universe, silent, invisible. Its only signature the agonizing screams of worlds torn asunder. We watched, powerless, as our magnificent gas giants, once symbols of constancy and protection, were reduced to broken behemoths, their gravitational dance turning into a struggle for survival. They could never win. Their grandeur was stripped away, their moons scattered, their rings annihilated. And with each destruction, with each catastrophic event in the outer solar system, we knew, with a deepening dread, that the black hole was getting closer. Its hunger was insatiable. It had devoured the distant ice worlds, shattered the rings of Saturn, and scattered the moons of Jupiter. And now, its gaze, its silent, invisible gravitational gaze, was turning toward the inner solar system, towards the storm that began with icy bullets was now a raging hurricane, tearing apart the very fabric of our cosmic home. The black hole was coming, and our world, our beautiful, fragile blue marble, was next on its menu. What happens when the giant's fury turns its sights on our tiny home? When the cosmic abyss reaches for Earth itself? The answer, I promise you, is beyond anything you can possibly imagine. The black hole was coming, and our world, our beautiful, fragile blue marble, was next on its menu. What happens when the giant's fury turns its sights on our tiny home? When the cosmic abyss reaches for Earth itself? The answer, I promise you, is beyond anything you can possibly imagine. For eons, Earth has been our sanctuary, a blue-green jewel hurtling through the cosmos, protected by an invisible shield and a delicate dance of gravity. We built empires, wrote symphonies, dreamt of the stars from its surface. But now, that sanctuary, that home, was about to face a nightmare far more ancient and terrifying than any human-made horror. The initial signs were subtle. A slight wobble in our orbit, barely measurable by our most sensitive instruments. Scientists, their faces etched with a new kind of dread, watched as the Earth's gravitational rhythm, once so steady, began to hiccup. It was like feeling the first tremor before a massive earthquake, a deep, unsettling thrum from an unseen force. The black hole, still millions of miles away, was already toying with us, its immense gravity a phantom limb reaching out, testing the very fabric of our planet. You see, a black hole doesn't just pull, it stretches. Its gravity isn't uniform across a body like Earth. The side of our planet, facing the black hole, feels a stronger tug than the side facing away. It's a differential force, what we call tidal forces, and they're what give the ocean its tides. But these weren't the gentle tides of the moon. This was the universe's most extreme gravitational gradient, beginning to stretch and compress our entire world like a cosmic stress ball. Imagine our planet, that solid, unyielding rock beneath our feet, suddenly becoming elastic. The crust, once a rigid shell, groaned under the strain. Fault lines, dormant for millennia, began to awaken with a shudder. The seismic sensors that once registered distant quakes now buzzed with a constant growing hum. Earth's tectonic plates, those colossal puzzle pieces that make up our continents, were no longer gliding serenely. They were being pulled, twisted, and jammed against each other with unimaginable force. Then came the quakes. Not the Richter 7s or 8s we occasionally endure. These were Richter 10s, 11s, perhaps even 12s, numbers once thought theoretically impossible. Mega earthquakes. They didn't just shake cities, they tore continents apart. Imagine entire mountain ranges, born from eons of slow, steady pressure, suddenly shattering, their peaks dissolving into dust and rock slides so vast they reshaped the landscape in minutes. Valleys ripped open, swallowing cities whole. Coastlines once familiar were now ragged scars, their edges frayed by an unseen hand. The very ground we stood on was no longer stable. It was a living, convulsing entity, trying to tear itself apart. And with this violent stretching, the Earth's molten heart began to churn with unprecedented fury. Deep beneath our feet, the liquid iron core, responsible for our protective magnetic field, was being roiled like a stormy sea. Its once stable currents became a chaotic maelstrom, and as the core spun out of control, our planet's magnetosphere, that invisible shield that deflects deadly solar winds and cosmic radiation, began to flicker. It weakened, then it collapsed. Suddenly, the sky itself betrayed us. The beautiful auroras, those dancing lights at the poles, amplified into terrifying, shimmering curtains of death, visible across the globe. They weren't just pretty light shows anymore. They were the visible manifestation of lethal cosmic rays, slamming into our atmosphere, cooking everything in their path. Electronics fried. Communication networks went silent. GPS, once our navigational lifeline, became useless. Humanity was suddenly blind, deaf, and disconnected, left exposed to the raw, unfiltered fury of the cosmos. But the chaos didn't stop there. The internal pressures, the violent churning of the core, found release. Supervolcanoes, dormant for hundreds of thousands of years, erupted with a ferocity never before witnessed by humanity. Yellowstone, Toba, Long Valley, sites of ancient cataclysmic eruptions, now exploded in unison. Plumes of ash and sulfur kilometers wide, clawed their way into the stratosphere, blocking out the sun. Day turned to an eternal twilight, then to an absolute choking darkness. The air became thick with volcanic dust. Acidic rain began to fall, and global temperatures plummeted, even as the planet itself overheated from within. Imagine the Earth, gasping for breath, spewing its guts into the sky. Life, already struggling with the constant quakes and radiation, now faced a new insidious enemy: suffocation. The air became unbreathable for many, a toxic cocktail of ash, sulfur dioxide, and other deadly gases. For those who survived the initial cataclysms, survival became a desperate, losing battle against a planet actively trying to purge them. And then, the oceans. Oh, the oceans. They became the ultimate weapon. The same tidal forces that tore apart the land now wrestled with the vast bodies of water. The black hole's pull created not just tides, but colossal bulges, drawing the ocean itself up into mountainous walls of water. Imagine a tsunami, not just from an underwater earthquake, but from the very fabric of space-time, pulling the sea upwards, creating waves kilometers high. These weren't just waves. They were liquid continents, moving at impossible speeds, smashing into coastlines with the force of 1,000 nuclear bombs. Cities were not merely flooded. They were scoured from the face of the earth, their foundations ripped from the bedrock. Entire island nations vanished beneath the crushing deluge. The familiar contours of our continents were erased, reshaped by a watery hammer blow. The roar of the oceans, once a soothing sound, became the terrifying symphony of our demise. In the face of such overwhelming, indiscriminate destruction, society fractured, order collapsed. What was the point of laws, of money, of nations, when the ground beneath your feet was tearing itself apart and the sky was raining death? People didn't just panic, they despaired. Governments, if they still existed, were helpless. Their armies, their technologies, their grand plans, all rendered utterly meaningless by a force that didn't care about our petty struggles. Scientists, once the calm, rational voices of reason, watched their simulations unfold in real time, their faces a mask of profound grief. They had predicted this, yes, but to witness it, to feel the very ground shaking beneath their feet, to see their home utterly undone, it was beyond comprehension. Their hope, their fear, their failures, their triumphs, all were swallowed by the cosmic abyss. There was no escaping this, no bunker deep enough, no spaceship fast enough. This was the end, and the universe didn't even notice. Humanity, once so proud of its dominion over this planet, was reduced to a desperate, scrambling species, clinging to a world that was actively trying to shake it off. The agonizing realization dawned on everyone. We were insignificant, a speck on a speck, caught in the indifferent, crushing maw of cosmic forces we could never hope to control. Our struggles, our triumphs, our entire history, all of it was just a fleeting whisper in the face of this silent, invisible horror. The Earth, our beautiful, resilient Earth, was no longer a sphere. It was beginning to distort, to elongate, to convulse. Its surface, once vibrant with life, was now a tortured landscape of impossible mountains, chasms, and supervolcanoes erupting beneath an ash-choked, radiation-scarred sky. The oceans, a boiling, churning tempest, consumed what little land remained. The planet itself was screaming, twisting, as if trying to tear free from the invisible grip of its tormentor. The black hole was closer now, close enough that its gravitational embrace was no longer just stretching Earth, but beginning to knead it like dough. The planet was losing its fight, its structural integrity failing. It was almost ready for the final act, for the ultimate horrifying process that awaited it. Earth, our home, was about to be unmade in a way we can barely conceive. The ultimate destruction was no longer a theoretical threat. It was an imminent, terrifying reality. And what comes next? What comes next will redefine the very meaning of annihilation. The planet itself was screaming, twisting, as if trying to tear free from the invisible grip of its tormentor. The black hole was closer now, close enough that its gravitational embrace was no longer just stretching Earth, but beginning to knead it like dough. The planet was losing its fight, its structural integrity failing. It was almost ready for the final act, for the ultimate horrifying process that awaited it. Earth, our home, was about to be unmade in a way we can barely conceive. The ultimate destruction was no longer a theoretical threat. It was an imminent, terrifying reality. And what comes next? What comes next will redefine the very meaning of annihilation. Look up. If you could somehow survive the cataclysmic surface, if you could brave the superheated atmosphere, you'd see it. Not with your eyes, not as a physical object, because black holes, by definition, are invisible. They're the ultimate cosmic stealth predators. But you'd see its effect. The sky, once a familiar canvas of blue and white, then a violent tapestry of red and black, is now something utterly alien. It's bent. Stars, constellations you've known your whole life, are no longer in their rightful places. They're not just smeared by atmospheric dust. They're stretched, like digital photos pulled too far, pixels distending into impossible lines. The Milky Way, our home galaxy, is no longer a gentle band of light. It's an arc, a distorted, shimmering rainbow, its familiar form pulled into a terrifying smile across the heavens. Distant galaxies, billions of light years away, are now visible in triplicate, mirrored, or even formed into a complete circle of light, a phenomenon known as an Einstein ring. It's beautiful, in a horrifying way. It's the universe itself, turned into a cosmic funhouse mirror. This, my friends, is gravitational lensing in full, terrifying effect. It's the signature of the void, the calling card of a monster that twists reality itself, and it's growing. That distortion, that central point of nothingness, where all the light vanishes, is expanding. It's no longer just a smudge. It's a looming, visible presence in the sky. Not a hole in the sky, but a hole of the sky. A perfect, consuming circle of absolute black, edged by the warped, smeared light of a million stars and galaxies. It's the maw of the void, opening wide to swallow everything we know. The very fabric of space-time around us is no longer stable. Einstein told us that gravity isn't just a force, it's a curvature of space-time. And right now, Earth is tumbling down, a gravitational well so steep, so profound, that space-time is screaming. What does that mean for us? For you, standing on that tortured ground, time itself would begin to warp. Clocks on one side of a mountain might tick infinitesimally slower than on the other. Shadows would behave bizarrely, not just bending, but seeming to crawl across the ground, stretching and shrinking independently of their light source. The air around you, if any breathable air remained, would shimmer, distorting your vision not through heat haze, but through the bending of light itself. Your perception would be shattered. Up is down, left is right, and the looming black circle above. It's not just a visual. It's a visceral presence. You can feel it. A crushing weight on your very soul. Earth's orbit, once a stable, predictable dance around the sun, is now a death spiral. Each revolution brings us closer, faster. The gentle elliptical path has tightened into a murderous coil. We're accelerating, plunging inward, picking up speed with every agonizing second. The black hole's gravity isn't just strong, it's differential. Think of it like this. The side of Earth facing the black hole is being pulled significantly harder than the side facing away. This isn't just a tug of war. It's a cosmic torture rock. The planet groans under the strain. Imagine holding a rubber ball and trying to stretch it in opposing directions with impossible force. That's Earth now. Its molten core, once a stable engine, is tearing apart. The crust, already fractured and convulsing, can't hold. Fissures open wider, deeper, swallowing entire continents. Magma erupts, not just from volcanoes, but from mile-long cracks. That spiderweb across the surface, painting the landscape in rivers of fire. The oceans, already boiling, are now sloshing back and forth across the planet in unimaginable tidal waves, sometimes hundreds of miles high, as the black holes pull, sloshes them like water in a bathtub, caught in an earthquake. And as we plunge deeper into that gravitational well, the tidal forces intensify exponentially. This isn't a gentle stretch anymore. This is the beginning of spaghettification. It's a term that sounds almost comical, but the reality is anything but. Imagine your body. If you were falling feet first into a black hole, your feet would be pulled with vastly more force than your head. Your ankles would be pulled harder than your knees harder than your hips, and so on. The result? You'd be stretched, thinner and thinner, longer and longer, until you were a mere stream of atoms, an infinitely thin strand of cosmic spaghetti. Earth is experiencing this now, but on a planetary scale. It's not just stretching, it's being unmade. The solid rock of the continents is no longer solid. It's becoming plastic, deforming, twisting. The planet is no longer a sphere. It's an ovoid, a teardrop, a grotesque, pulsating blob being pulled into an infinitely long, infinitely thin strand. The atmosphere, what little remains, is stripped away, torn from the planet's surface, spiraling into the void. The oceans vaporize, then ionize, joining the stream. The light from the sun, our life-giver, is now just another victim of the black hole's gravity. It's bent, distorted, smeared, a final dying ember in a sky consumed by the encroaching darkness. And that darkness, it isn't merely the absence of light. It's an absolute fundamental emptiness, a place where the laws of physics as we know them break down, a place where nothing can escape, not even light itself. It's the ultimate prison, the ultimate end. The Earth, our beautiful blue marble, our home, is now a grotesque parody of its former self. It's a comet of rock and fire, its surface molten, its interior ripped apart, its shape distorted beyond recognition. It's spiraling, faster and faster, a screaming, dying ember, accelerating towards the inevitable. The point of no return, the event horizon. There is no buy, no final explosion, just a silent, absolute consumption. One moment, a tortured, elongated planet. The next, nothing. Just the expanding blackness. The Earth, its mountains, its oceans, its history, its life. Everything is gone, reduced to an infinitely thin stream of elementary particles, stretched and absorbed into the singularity, the dimensionless point of infinite density at the heart of the black hole. Our planet, our entire world, is now just another meal for the cosmos' most efficient predator. Not even a whisper remains. For the universe, it was just a fleeting event. For us, it was the end of everything. You've witnessed the solar system descend into cosmic chaos. Planets ripped from their orbits, moons flung like pebbles, the serene ballet of our home replaced by a mosh pit of gravitational madness. But now, as Earth plunges headlong into the gravitational maw of that rogue black hole, the real horror truly begins. This isn't just about being pulled. It's about being unraveled. Imagine for a terrifying moment, you're standing on that Earth. The sky, it's a canvas of impossible distortions. Stars, once familiar, are now smeared across the heavens, their light bent and twisted into impossible arcs, like a cosmic funhouse mirror. And then you see it, the black hole itself, not as a gaping maw, but as a perfect inky sphere, a void against the backdrop of warped starlight. It's not reflecting light, it's devouring it. Around its edges, a thin superheated ring of gas and dust, leftover debris from unlucky encounters, swirls at impossible speeds, the last bright beacon before absolute darkness. It's a vision so alien, so profoundly unsettling, it would shatter your mind long before the gravity shattered your body. The forces at play here are beyond anything our planet has ever experienced. We call it disturbances, spaghettification fires, and it's not a cute nickname. It's a scientifically accurate, utterly terrifying description of what happens when a body, any body, gets too close to a black hole. Think about it like this. Gravity isn't a uniform blanket. It's a gradient. The closer you are to a massive object, the stronger its pull. For us on Earth, the difference in gravity between your feet and your head is negligible. You don't feel it. But a black hole, its gravity well, is so steep, so extreme, that the difference in pull between the side of Earth facing the black hole and the side facing away becomes immense, astronomical. Suddenly, our planet isn't just being pulled, it's being stretched. Imagine a giant invisible hand grabbing one end of a rubber band and another giant invisible hand grabbing the other and pulling with impossible force. That's Earth. The side closest to the black hole is being yanked harder, much harder, than the side furthest away. From space, our familiar blue marble would start to look like something out of a nightmare. Not spherical, not even oval, but elongated, distended, like a teardrop caught in an invisible current. The oceans, oh, the oceans, they wouldn't just slosh, they'd surge. Tides not feet or miles high, but hundreds, thousands of miles. Vast walls of water racing across continents that are themselves groaning, cracking, splitting open. Our simulations, run by brilliant minds with supercomputers churning unimaginable data, show a planet in agony. The Earth's crust, once a solid foundation, fractures into a million pieces. Continents once stable are torn apart, their jagged edges grinding against each other, creating seismic events that make our most powerful earthquakes look like mere shivers. Volcanic eruptions, not just from isolated peaks, but from vast new fissures ripping open across the entire globe, spew molten rock and ash into a sky that is already a swirling vortex of distorted light and shadow. The atmosphere itself, once our protective blanket, is stripped away, howling into the void, leaving a vacuum punctuated by firestorms and impossible winds. And then, it gets even more intimate. As Earth stretches, its internal structure begins to unravel. The solid inner core, the molten outer core, the thick mantle, they're no longer distinct layers. They're becoming one, a churning viscous fluid, twisted and kneaded by unimaginable forces. The very magnetic field that protects us from solar radiation collapses, leaving any last vestiges of life utterly exposed to cosmic rays. Not that it would matter much at this point. The Earth, our home, is now a cosmic taffy pool. You'd see mountain ranges, once standing proud, begin to flatten, stretch, their peaks elongating into impossible needles. Valleys deepen, not by erosion, but by sheer gravitational force, pulling the land apart. Think of a piece of clay being rolled between two hands, getting thinner and longer. That's us. That's our planet. This process isn't instant. It's a terrifying crescendo. As Earth gets closer, the differential gravity, the tidal force, increases exponentially. What began as a slight bulge quickly becomes a dramatic elongation. The planet is no longer just stretching. It's being drawn into a long, thin stream, like a cosmic spaghetti noodle. Our simulations visualize this with a brutal elegance. From a distant vantage point, you'd see a blue-green sphere, then an egg shape, then a cigar, then finally a shimmering incandescent ribbon, miles wide, but hundreds of thousands of miles long, trailing towards the black hole's event horizon. And what about life? What about us? Long before this final, horrifying stretch, life on Earth would have ceased to exist. The atmospheric stripping, the global firestorms, the unimaginable tsunamis, the constant planet-shattering earthquakes, these would have rendered our world uninhabitable. But even if some impossible, resilient life form had managed to cling on, its fate would be just as brutal. As the planet stretches, so would everything on it. Imagine your own body being pulled in two directions at once. The force on your head, vastly different from the force on your feet. Your bones would snap. Your muscles would tear. Your very cells would rupture. Every molecule in your body would be subjected to forces that would literally pull it apart. Scientists call this the enorm tidal gradient, the difference in gravitational pull across an object. For a black hole, this gradient is so steep, so extreme, that it can overcome the electromagnetic forces that hold atoms together. Think about that for a second. The very bonds that give matter its structure, that define you, me, the chair you're sitting on, the air you breathe, those bonds are weaker than the black hole's differential gravity. So, as Earth continues its agonizing plunge, it's not just breaking apart into chunks, it's unraveling on a fundamental level. Its mountains, its oceans, its very bedrock are not just cracking, they're dissolving. They're being pulled apart, molecule by molecule, atom by atom. The planet becomes a river of fundamental particles, a shimmering incandescent plasma, stretched thinner and thinner, longer and longer, a ghostly ribbon of destruction, reaching out to its ultimate doom. And then, there it is, the event horizon. It's not a physical barrier, not a wall you can see or touch. It's a boundary of no return, a mathematical surface where the escape velocity, the speed you need to travel, to break free of gravity, exceeds the speed of light. And nothing in our universe can travel faster than light. Crossing the event horizon is the ultimate one-way trip. Once past that invisible threshold, there is no coming back. No signal, no light, no information can ever escape. Whatever lies beyond is forever hidden from us, lost to the universe. For anything that crosses it, time itself becomes distorted, stretching infinitely from the perspective of an outside observer, while for the object itself, its journey to the singularity is terrifyingly swift. The Earth, our beautiful blue marble, our home, is now a grotesque parody of its former self. It's a comet of rock and fire, its surface molten, its interior ripped apart, its shape distorted beyond recognition. It's spiraling, faster and faster, a screaming, dying ember, accelerating towards the inevitable. The point of no return, the event horizon. There is no bang, no final explosion, just a silent, absolute consumption. One moment, a tortured, elongated planet. The next, nothing. Just the expanding blackness. The Earth, its mountains, its oceans, its history, its life. Everything is gone. Reduced to an infinitely thin stream of elementary particles, stretched and absorbed into the singularity. The dimensionless point of infinite density at the heart of the black hole. Our planet, our entire world, is now just another meal for the cosmos' most efficient predator. Not even a whisper remains. For the universe, it was just a fleeting event. For us, It was the end of everything. For the universe, it was just a fleeting event. For us, it was the end of everything. And in that vast, indifferent cosmic theater, when the final screams of a dying world have faded, what then? What's left when our home, our history, our hopes, our very existence are swallowed by an abyss? Silence. Profound, absolute, echoing silence. The kind of silence that doesn't just mean a lack of sound, but a lack of everything. No light, no warmth, no vibration, just the cold, expanding void where a vibrant star system once danced. Our simulation, grim as it was, delivers this truth with unflinching honesty. The Earth, gone. But what about the rest of our cosmic neighborhood? Did the rogue black hole just move on, leaving behind a cosmic junkyard? Or did it devour more? The truth is, it depends. A rogue black hole, even a relatively small one, say, one with the mass of Jupiter, or even our sun, is an engine of gravitational chaos, unlike anything we've ever truly experienced. It's not a vacuum cleaner, sucking up everything in its path indiscriminately. Instead, as a cosmic wrecking ball, a gravitational tsunami that reshapes everything it touches. Imagine the sun. If the black hole passed too close, our star, a stable furnace for billions of years, could be stripped of its outer layers, torn apart by tidal forces, its nuclear heart, exposed and extinguished. Our star, once a beacon of life, would become a cold, dark cinder, perhaps even collapsing into a white dwarf or neutron star, its light gone forever. More likely, if the black hole didn't score a direct hit on the sun itself, it would have flung our star violently out of the Milky Way, sending it careening into interstellar space, a lonely exile. The remaining planets, those that weren't directly spaghettified, would have been scattered like marbles on a tilted table. Jupiter, Saturn, Uranus, Neptune. Touched, these gas giants, once majestically orbiting our sun, would become rogue planets themselves, hurtling through the cold, dark expanse between stars. Lifeless, yes, but still intact, forever adrift, a cosmic diaspora, and the black hole itself. It would simply continue its silent journey, unchanged, uncaring, a ghost in the machine, leaving behind a trail of cosmic devastation, perhaps picking up a stray asteroid or two along the way. For it, our solar system was just a momentary gravitational bump in its eternal wanderings, a blip on an unimaginably long journey across the galaxy, or perhaps even beyond. This isn't a horror story, not really. It's a reality check, a stark reminder of our place in the cosmos. We humans, with our intricate societies, our profound emotions, our soaring dreams, we tend to put ourselves at the center of the universe. We measure time in heartbeats and lifespans. We see our planet as unique, our existence as paramount. And in many ways, it is, for us. But for the universe, for the cold, vast, indifferent machinery of space-time, we are less than a speck. Our entire solar system, a fleeting arrangement of matter and energy. It's a humbling thought, isn't it, to realize that the universe isn't out to get us. It's not some malevolent force plotting our demise. It just is. It operates by its own immutable laws. And those laws, while capable of creating breathtaking beauty and complex life, are equally capable of unleashing unimaginable destruction without a second thought, without a shred of malice, just the inevitable consequence of mass, energy, and gravity doing their thing. Think about it this way. Right now, as you're watching this, somewhere out there, in the unfathomable expanse of the universe, a star is dying. A galaxy is colliding. A planet is being born. Or perhaps like our simulated Earth, being torn asunder by a rogue wanderer. These events are happening constantly. on scales that utterly defy our comprehension. And each one, for the beings who might inhabit those worlds, represents the end of everything. But for the universe, it's just another Tuesday, a cosmic whisper, barely audible in the vast symphony of creation and destruction. This simulation isn't about fear, or at least it shouldn't be. It's about perspective. It's a mirror held up to our own precious, improbable existence, because while the universe might be indifferent, we are anything but. Our ability to even conceive of a rogue black hole, to simulate its terrifying dance, to understand the physics of spaghettification, whoa. That's what makes us extraordinary. That's the human spirit in action. For centuries, millennia even, we looked up at the night sky and saw gods, myths, patterns. We saw a comforting, predictable canopy. But then we invented telescopes, physics, mathematics. We dared to look closer, to ask harder questions, and what we found was a universe far grander, far more complex, and yes, far more dangerous than we ever imagined. Yet, instead of shrinking in fear, we expanded our understanding. We built space probes that now whisper to us from the very edges of our solar system. We launched telescopes that peer back in time, showing us the universe as it was billions of years ago. We are driven by an insatiable curiosity, a primal urge to know, to understand, to map the unknown, even when the map reveals terrifying truths. That's resilience. That's the enduring human spirit. To look ultimate destruction in the face, to simulate it, to understand it, and then to turn that understanding into a deeper appreciation for the miracle of our own fleeting moment. We are here, on this fragile blue marble, spinning through a cosmic shooting gallery, bathed in the light of a star that is itself just one of billions. And against all odds, we are alive. We are conscious. We are capable of wonder. This planet, our Earth, is a sanctuary, a tiny, improbable oasis in a vast, mostly hostile cosmos. We are protected by a delicate atmosphere, warmed by a perfectly positioned star, shielded by a powerful magnetic field. Everything, from the delicate balance of gases in our air to the precise tilt of our axis, has conspired to create the conditions for life. And not just any life, but intelligent life. Life capable of contemplating its own cosmic insignificance, yet finding profound meaning in it. The simulation of a rogue black hole reminds us that our biggest threats aren't always self-inflicted. Sometimes they come from the deep, dark, indifferent cosmos. But it also reminds us that the greatest gift we have is this moment, this shared experience on this magnificent planet. Every sunrise, every breath, every connection we make. They are infinitely precious because they are infinitesimally rare. So, when the simulation fades to black and the screams of a dying world are just echoes then in the abyss, what remains? The knowledge, the understanding, the quiet, profound appreciation for what we have right now. It's a call to cherish this improbable existence, to protect this fragile blue marble, not just from cosmic invaders, but from our own follies, because we are, in every meaningful way, all we've got. And this beautiful, dangerous universe is our only stage. What other cosmic dangers lurk in the shadows, waiting to reshape our understanding of existence? The universe has more secrets than we can possibly imagine, and we're just beginning to unravel them.